A very good morning, my dear students. So last class, what was the topic? The nomenclature of coordination compounds, right? So today's session, let us discuss the remaining coordination compounds and their IUPAC name, nomenclature, right? So already we have discussed 8 coordination compounds. This is 9th one. Here coordination sphere is given, left side, right side, no elements or ions are present, right? So now, which type of ligands are present here? We have to see carbonyl, then 5. This one P3 means triphenyl phosphate, right? These two are neutral ligand. Then the chromium charge also will be neutral because the total coordination sphere charge neutral, right? So this kind of coordination compounds, by which how to write the IUPAC names. According to the alphabetical order, the carbonyl will come first. So 5 means pentacarbonyl. 3 means triphenyl. PH means phenyl. Triphenyl. Phenyl is C6H5 actually, right? Triphenyl. P. Phosphate. Triphenyl phosphate. As to the phosphate formula, P(3), replace a hydrogen, 3-phenyl is substituted, right? So pentacarbonyl, triphenyl phosphate, then chromium, the charge is 0, right? Charge is 0, right? Now the 10th compound, here we see which type of ligands. Amine is here, right? And NO2 means nitrite 2. The amine is a neutral ligand. Nitrite 2, NO2 charge -1. Here thrice. So totally -3. Right? 1 NO2 -1, 3 NO2 -3. Here the cobalt charge +3. So total coordination sphere charge +3 -3 added means 0. Right? Okay. So further how to write the IUPAC name we will see. According to the alphabetical order, amine will come first. So triamine, nitrito. Here the nitrito is an ambidextrous ligand. Ambidextrous means NO2 ambidextrous ligand ONO, right? Here the NO2 from nitrogen we can make a coordinate bond with the cobalt. The coordinate bond comes from nitrogen in NO2. So this kind of ambidextrous ligand present means here we can mention it K, small k, N. So what is the meaning? The coordinate bond comes from nitrogen to central metal atom cobalt, right? So Kn. Here cobalt oxidation state +3. You can give with Roman numeral, right? That's all. Their total charge is 0. So thereafter we can leave it, right? Next, the 11th compound we see. 11th compound, which type of ligands? Water is here, so aqua. Here nitrito. The previous one we can see NO2 ambidextrous ligand, ONO. These two are ambidextrous ligand. Here the covalent bond comes from oxygen to palladium, right? Here water is aqua, ligand name is aqua, charge is neutral. Here charge O charge minus 1, so here 2, so totally minus 2. Iodo, 1 iodine minus 1, 2 iodo, so minus 2. So the total charge of the coordination sphere will be 0. So what is the actual oxygen state? Palladium plus 4. So how to write the IUPAC name? We will see. According to alphabetical order, aqua will come first. So diaqua, dinitrato, nitrito. The nitrito is an amine ligand, so we can mention it. The covalent bond comes from oxygen, so KO. So K means amine ligand. The term K means amine ligand. The hyphen will come front of the K, right? So KO. Right? Here. So before the dinitrito, we can write diiodo. According to alphabetical order, diaqua and diiodo. Iodo will come first. Iodo. Next, nitrito, right? Then hyphen, the amine ligand nitrito. Okay, we can mention it. The covalent bond comes from oxygen, so oxygen O. Next, palladium. Palladium charge, oxygen state plus 4. We can mention with the Roman numeral, right? Okay. Next, the 12th compound we see. The 12th compound, 2 coordination sphere are present, right? These are coordination isomer of the compounds, right? 2 coordination spheres are present. So one will be positive, another one will be maybe negative. So now we can make a charge. Here 2 types of ligand present in one coordination sphere. We know that amine is a neutral ligand. Then chlorido, 1 chlorido minus 1, 2 chlorido minus 2, right? Here the cobalt charge is plus 3, and the total coordination sphere, the left side, plus 3 minus 2 means plus 1 will come. The suffix 3 is given. The total charge will be plus 3, right? That's why it is given 3. Here, right side, the coordination sphere charge is, you see, cyanide, 1 cyanide minus 1, so 6 cyanide minus 6, the chromium plus 3, so total charge minus 3, right? Actually, the plus 2 suffix 3 is given, so multiple with 3 means we can get plus 3. So plus 3 and minus 3. The charges are balanced. Now we can start the IUPAC name. Okay, the first coordination sphere, left side, we can solve it. 4 means what? Tetra. Amine. Amine. 2. Di. Cl means what? Chlorido. Cobalt. Cobalt charge, oxygen state plus 3. So mentioned with the Roman numeral plus 3, right? Okay, below that you can write here the IUPAC number of the another coordination sphere, right? Hexa, cyanido, hexacyanidO, chromium. The chromium total coordination sphere charge -3. So that's why, so negative, ending with a negative coordination sphere. So chromate we can write it. So chromium stands to chromate because the total coordination sphere charge negative -3, right? So chromate. So carefully we have to write the oxygen state +3. So we can mention with the Roman numeral, right? So Roman numeral we can give inside the bracket, right? Okay. Now the 13th compound charge separation we see here. CyanidO -1, amine neutral ligon, cobalt +3. So total +2, right? So this one right side coordination sphere will be -2. So how will come? Amine 0 ligon and cyanidO -5, cobalt +3 added with the -5 means it gives -2, right? So let us write the IUPAC name. According to alphabetical, amine will come first. So penta amine, cyanidO. Here the cyanidO is an ambidynate ligon. So previous one, the 12th compound also. So left side no ambidynate ligon, right side ambidynate ligons are present. So C and NC are possible. So the cyanidO, so we can mention it, ambidynate ligon. So hexacyanidO, here Kc will come, right? Kc, that also we should mention here. Kc means the coordinate bond come from carbon, we can mention it, right? Okay, after that chromate 3. Now the 12th compound, just now we have started, pentaamine cyanidO. Here Cn is a ambidynate ligon. So Kc, chromium, not chromium, Co, cobalt, oxidation state +3, right? Here hyphen. Next, the right side coordination sphere. So ending with a negative. So carefully we got to write it. Here amine, pentacyanidO, cobaltate. So ending with a negative coordination sphere, right? -2. So before we can mention the central metal atom ambidynate ligon, whether it is present or not present, right? So Kc, the coordinate bond comes from carbon. So Kc, cobaltate, ending with the negative side. Cobaltate, Roman letter 3, oxidation state mentioned the Roman letter, right? So still we have completed with the ambidynate ligons, right? Now the 14th one, two coordination sphere are given, but here ambidynate ligon is not, right? So pyridine, P1 means pyridine ligon. Pyridine is a neutral ligon, right? So right side we see, then only we can get the charges. Here 4 Cl, chlorido, so -4, the platinum charge +2, so totally -2, so this one +2, the +2 belongs to platinum, right? Now we can write the IUPAC name. Tetra 4 PY means pyridine. Tetrapyridine, platinum, oxidation state 2, so So mentioned with Roman numeral 2. So right side we see. So ending with the negative coordinate sphere. So tetra chlorido platinate. Why platinate is given? Because the coordinate will be charged -2. Platinate, Roman letter 2. Also mistake mentioned with the Roman letter 2. Right? Now the 15th one. 15th one is bidentate ligands are present. Bidentate ligands En is given. Right? En twice. So En means ethylene diamine. Ethane 1,2 diamine we can write it. From ethylene 1,2 diamine, 2 coordinate bond formed with the central metal atom cobalt, right? So totally 2 coordinate bond and 2 coordinate bond come from ethane 1,2 diamine and chloride also 2. So totally 4 coordinate bond because twice, right? So we see how to give the name. The ethylene diamine, so neutral ligand, bidentate ligand is neutral ligand, so -2. This one +3, cobalt just +3. So +3 -2 means +1. So out of the coordinate sphere, chlorine is here, so -1. Now it is neutral, right? Now we can write the IUPAC name. Dichlorido. So ethylene diamine, ethylene 1,2 diamine, right? The ligand name is ethylene 1,2 diamine. So it's a bidentate. So 2 is here, suffix 2. So 2 means bis, BAS. So ethane 1,2 diamine we can mention in the bracket. Ethane 1,2 diamine, AMINE. WM will not come, right? WM will not come, single M only, because the formula NH2 CH2 NH2, right? So NH means amine, DIAMINE. We can close the bracket. Then cobalt oxidation state +3. So ending with a negative ion chloride, right? Okay. The last one, 16th coordination compound Na2, inside the bracket nickel, EDTA is given, and close the bracket, right? So here the charge is EDTA -4, right? So nickel charge +2. So totally coordination sphere charge -2. Here 2 sodium, totally +2, right? So we can write. So what kind of rules? Positive must write first. So out of the coordination sphere, Na2 is given with the positive. So sodium. And EDTA means ethylene diamine tetraacetic acid. We can say that. But here the EDTA acts as a ligand. So ligand name we can mention it. So what is the position? The sodium we can write it. Next 2, 2 dash, 2 double dash, 2 triple dash, right? The ethane, EDTA means how to write it? Ethane 1,2 dinitrilo, dial, DIYL, DINITRILO, right? Nitrilo. So you can close the bracket. Tetraacetate, right? The position of the coordination bond 2, 2 dash, 2 double dash, 2 triple dash. Then nickelate, nickel total coordination sphere charge minus 2. So nickelate, nickel charge 2. It is also a state. You can mention with the Roman numeral, right? So now just I explain this compound. How will be the EDTA? EDTA we can mention it. Ethane 1,2 diol dinitrile tetraacetate. So how will be the EDTA compound? CH2 bond CH2, left side one N, right side one N, right? And here CH2 COO minus, CH2 COO minus, then CH2 COO minus, CH2 COO minus. So 4 coordinate bond, right, given to the central metal atom. That's why given the ethane 2 carbon, ethane are all single bond. So ethane 1, 2, 1, 2 1, 2 diol, diol means CH2 bond, CH2 means diol, and the CH2 again left side right side bonded with nitrogen. So dinitrile tetraacetate, tetra so 4 acetate is present. So tetraacetate, right? So what is the position? The tetraacetate position, 4 positions are 2, 2 dash, 2 double dash, 2 triple dash. That is given. Sodium 2, 2 dash, 2 double dash, 2 triple dash, ethane 1, 2 diol dinitrile tetraacetate, nickelate. Total coordination charge minus 2. That's why 8. Sodium oxygen state, nickel oxygen state 2, mentioned with the Roman numeral, right? Okay, thank you.